Hi friends, myself GG Balaji from 2nd MSc Microbiology, Central University of Tamil Nadu, and my topic is about advanced bioremediation practices. First, we will see what is meant by bioremediation. Bioremediation is nothing but it is the process of reduction, elimination, and alteration and transformation of contaminant by the biological vectors like bacteria, fungi, green plants, and the enzymes. There are many types of bioremediation. Here are some types I quoted here. They are bioaugmentation, biostimulation, phytoremediation, mycoremediation, nanobioremediation, electrokinetic remediation, microbial fuel cell, constructed wetlands, genetically modified organisms, sustainable bioremediation. Here I will explain about the first five, that is bioaugmentation, biostimulation, phytoremediation, mycoremediation, and nanobioremediation. So part 1. Part 2 will be explained by Kritika. Bioremediation is of two types, that are in situ bioremediation and ex situ bioremediation. In ex situ bioremediation, where the contaminants are removed and from the original site for treatment, whereas in situ the contaminants are removed in the same area where it is treated in the same area without removing it. First we will see what are the advantages of ex situ bioremediation, like controlled environment, like we are extracting the contaminant from the area, so it is controlled environment, and fast remediation typically results in quicker remediation than in situ bioremediation, higher efficiency, more effective than in situ bioremediation. Then we can see what are the advantages of the in situ bioremediation. Minimal disruption. We are not extracting the contaminant, so the environment will not be disturbed. Cost effective compared to ex situ. In situ is cost effective. Ecological preservation maintains local ecosystem and habitats. Next, we will see what is meant by bioaugmentation. Bioaugmentation is nothing but using of microorganism to bioremediate the place. In this image, you can see there is a contaminated environment where the microorganisms are added, and the black color dots are the pollutants. The the added microorganism digests the contaminant, and the successful bioremediation happens. As we can see there, the contaminant free environment is added. What are the microorganisms used in bioaugmentation is bacteria, fungi, and archaea, where bacterial strains like Pseudomonas, Bacillus, and Mycobacterium rhodococcus are commonly used in bioaugmentation, whereas in fungi, Chrysosporum trichoderma are employed in bioaugmentation for breaking down lignin, chlorinated hydrocarbon, and polycyclic aromatic hydrocarbon. Whereas, as you know, archaea will grow in extreme environment, so that we can use archaea in extreme environment bioremediation. Now we can see a case study about bioaugmentation. Exxon Valdez oil spill. In this oil spill, they used bioaugmentation technique to bioremediate the place. The Exxon Valdez oil spill was a major environmental disaster that was happened in 1989. Over 37,000 tons of crude oil is mixed in the sea. After the spill, bioaugmentation was used in Alaska to introduce hydrocarbon degrading bacteria. The bacteria are like Pseudomonas alcanivorous, Marinobacter oryspira, and Corynebacterium and Arthrobacter. These are the organisms they used to bioremediate those places which is contaminated by the oil spill. Next, we will see about biostimulation. Biostimulation is same as bioaugmentation, where we use microorganism to bioremediate, but in biostimulation we don't add any microorganism. Instead, we add nutrients to increase the growth of indigenous microorganism that is normally present in those environment, like adding nutrients which are essential to growth of those indigenous microorganisms. In this nutrition addition, the most common method of biostimulation is adding nutrients such as nitrogen, phosphorus, and other trace element, where the C/N ratio is maintained. The carbon source is from the contaminant. The microbes will take the carbon source from the contaminants. where the nitrogen, phosphorus and other sources were added by externally to increase their growth and used for bioremediation. First, the environment can be modified. Environment factors such as pH, temperature, moisture level, aeration can be modified to create an optimal condition for microbial activity. For example, oxygenation of groundwater or soil can enhance the degradation of organic contaminants like petroleum hydrocarbon or chlorinated solvents. Next, we will see the advantages of biostimulation. First, it is cost effective because we are not extracting the contaminant, we are not adding any microorganism, we are just adding the nutrients to increase the microbial growth of the indigenous microorganism. So it is cost effective. Environmental friendly, it enhances natural microbial process, make it an ecological sustainable solution. Long term effect, as biostimulation the organism growth is increased and the contaminants is reduced for long term, and population of microorganisms can adapt to the pollutants. Next, we will see the limitation of biostimulation, where biostimulation requires suitable environment condition. Like I already told, every microorganism has their own pH temperature. We should give the own pH temperature to increase their growth. Limited to biodegradable contaminants. In this, the biostimulation can only be used in biodegradable contaminant, where non-biodegradable contaminant cannot be remediated by biostimulation. Unintended consequences, like we are adding more nutrients to the place, it can cause algal bloom. It can cause eutrophication and algal blooms, which can cause greater disaster to the marine life and other marine organisms. In phytoremediation, instead of microorganisms, plants are used to bioremediate, like where certain plants are used to extract, degrade, and stabilize pollutant from the environment. It takes an advantage of natural process of plants, including their ability to absorb, store, and transfer harmful contaminants into less toxic forms. First, there are totally three types of phytoremediation. First one is phytoextraction, where the plants absorb the contaminants from the soil through the roots and they stored in their shoots and leaves. Then after storing, the plants can be harvested and disposed to eradicate the heavy metals. Where in the phytodegradation, the plants break down the organic pollutants such as pesticides, herbicides, or petroleum hydrocarbon into less toxic forms. The plant's enzyme transforms the contaminant into harmless byproducts. In biostabilization, the plant inhibits the spreading of contaminants to the other area. It stabilizes the contaminant by binding them to the soil or preventing their uptake into plant tissue. Here in the diagram, I given that the overview of phytoremediation, where the phytodegradation, phytovolatilization, phytostabilization, phytofiltration happens. Next, we will see the common plants used in phytoremediation. Sunflower is the effective for removing heavy metals like lead and uranium, whereas Indian mustard is known for its ability to accumulate cadmium, lead, and chromium. Poplar tree, often used for degradation of organic pollutant, whereas water hyacinth used for removing heavy metals from aquatic environment. We can see the case study Chernobyl and sunflower. As we all know, the Chernobyl nuclear disaster is happened in 1986, where the most radioactive elements are released in the environment. Where the government in Chernobyl, they planted sunflower flowers to reduce the radioactive isotopes from the soil and water. These sunflower took more radioactive element like cesium, strontium from the environment, helping to reduce the radiation level. Next, we will see about mycoremediation. Mycoremediation is same as bioaugmentation, but instead of bacteria and other organisms, we use fungi in mycoremediation to eradicate the pollutants from the environment, particularly in soil, water, and air. Fungi with the extensive mycelial network and unique enzymatic capabilities can break down complex organic pollutants and even accumulate heavy metals. This process is driven by fungi natural ability to decompose tough organic materials. As we all know, fungi will grow on tough organic materials like mushrooms, and others will grow in dead organic materials. Then we will see about types of microremediation. Microremediation of organic pollutants. Fungi, particularly white rot fungi, can degrade organic pollutants such as hydrocarbon, pesticides, synthetic chemicals through their lignin degrading enzyme. For example, Chrysosporium is capable of breaking polycyclic and polyaromatic hydrocarbon, making it valuable for cleaning up sites contaminated with industrial chemicals. Next, we will see microremediation of heavy metals. Some fungi, such as mycorrhizal fungi, form symbiotic relationship with plants can help them to tolerate and accumulate more heavy metals in their mycelium, reducing the concentration of these metals in the environment. Here is an example where the nectomycorrhizal fungi, which can absorb metal like lead and cadmium from the soil. The next type is mycofiltration, where the fungal mycelium is used for in cleaning the water by trapping and breaking down the contaminants. Microfiltration is particularly useful in treating agriculture runoff, stormwater, and other polluted water sources, where the mycelium traps the contaminant and degrades it. It is effective at filtering pathogens, bacteria, and organic contaminants. Here is another case study about mycoremediation. It is a mycoremediation of oil contaminated soil. In this study conducted by Paul Stamets, a leading researcher in mycoremediation, he used oyster mushroom, that is Pleurotus ostreatus, where it is used to remediate oil contaminated soil. The, the fungi like oyster mushroom broke down the hydrocarbon in the soil, turning the toxic into the non-toxic and fertile. The mushrooms degrade up to 95% of oil contaminants. It is only 5% it is not degraded, demonstrating the potential of fungi for bioremediation of oil spills and other hydrocarbon related pollutions. Next, we will see what are the common fungi that are used in mycoremediation. First one is white rot fungi like Cryosporium and Tramatus versicolor, effective for breaking down organic pollutants including dyes, hydrocarbon, and pesticides. In oyster mushroom, we already see in case study it is used to degrade oil and petroleum products. Turkey tail fungus, Tramatus versicolor, effective in breaking down synthetic chemicals and pesticides. Aspergillus niger, often used for heavy metals bioaccumulation. Next, we will see about nano bioremediation. This innovative approach where the principle of nanotechnology and bioremediation is combined. It involves using of nanomaterials in conjugation with biological process to degrade, detoxify, or removal of environmental pollutants. The environmental pollutant may be heavy metals, organic contaminant, and other hazardous substance. There are majorly two components in nanobioremediation, that are nanomaterials and the microorganism. Nanomaterials are employed to enhance the efficiency of bioremediation. The material possess unique physical and chemical properties due to their small size, large surface area, and high reactivity. Whereas in the other component in microorganism, the biological component typically involves bacteria, fungi, algae, and plants that naturally degrade pollutant through enzymatic process. In nanobioremediation, microorganisms may be modified or enhanced by the presence of nanomaterial to improve pollutant degradation or uptake. Next, we will see the type of nanomaterial that are used in nanobioremediation. The first nanoparticle is zero-valent ion nanoparticle. These are widely used to remediate soils and groundwater contaminated with fluorinated organic compound, heavy metal, and other toxic chemical. It reduced pollution via process electronic transfer and transforming harmful chemicals into non-toxic forms. The next one is silver nanoparticles. They have antimicrobial property. As we all know, silver have antimicrobial activity and they are used in many grafting in the tissue. It can be also used to target microbial contaminant in water and soil. Next one is magnetic nanoparticle. These particles can be functionalized to bind contaminants and easily removed from water or soil using magnets, offering a high selective cleanup process. Next we will see carbon-based nanomaterials. First one is carbon nanotubes. They can absorb organic contaminants such as pesticide dyes and heavy metals. They can also be combined with microorganisms that degrade the absorbed pollutant. Next one is graphene oxide. Graphene based material have a large surface area so that they can be used to absorb heavy metals and organic contaminants from the soil. The third type is nanoclays. Nanoclays can trap both the organic and inorganic contaminants, enhanced natural biodegradation, providing support for microbial communities. These are my reference, and thank you Kavya ma'am for giving me this opportunity. Thank you all.